Okay, so now we have to look at some reservoirs. Now, reservoirs are really important sources of water because they allow us to store water from seasonal surpluses. So in the winter, when it's raining a lot, we can store that and use it over the winter. The additional benefits are because they are low energy environments, the water is static, all the suspended solids will settle out and the UV of the sunlight that falls upon the static water helps kill pathogens, and this makes it much cheaper to treat the water. So that's a really good benefit. So reservoirs, when we want to build them, we have to do site selection, and there are 8 different factors that we need to consider when we are choosing our location. So the first one is topography. So topography means like the shape of the earth, like is it a hill or a valley? Um, and what we're looking for is to get the smallest possible dam because this is the expensive bit. And we're looking to get the largest volume of water because this is where we make our money. So what we want is a topography where the hills form a large basin with a narrow exit. So I don't know why I've drawn it over there. That's a silly place to put it, isn't it? A narrow exit. And this means it costs a lot less to build. So it's cheaper. Whereas if we had this topography here where we've got a large basin but a wide exit, this means that it is much more expensive to build for the same volume of water. So the next one we want to look at is the geology. So we're looking at how permeable the rock is. We want it impermeable to prevent percolation. So that this means that we store that water and it doesn't seep away. However, there are occasions where you do want the water to percolate in, and this is if you are using the reservoir to recharge aquifers. Then you do want it to be permeable. And you also need it to be strong. Now, having it strong is really important because it will prevent the dam from collapsing because it will be able to support the weight of the dam and reservoir, which can be extremely heavy. The other thing is the weight of all that water and the mass of concrete or earth that makes the dam can actually cause movement of the plate underneath it and can cause seismic activity. And this can cause things like faults, and this will damage the dam. And this has happened in a number of occasions around the world. The next one then is catchment area. So this is the area of land where precipitation will end up in the reservoir. So we want a large catchment. We want a large volume of water that falls onto it. And we want a large base flow ideally, so it's flowing all year round. We don't have to build the reservoir high up in a catchment. It can actually be further downstream. So we can have it downstream of a mountainous area and then build the reservoir in something like a gorge where the river flows through. And you find that in a lot of more arid countries. That's the sort of thing you might do because they have higher precipitation rates in the mountainous areas. The next one then is a water supply. So you need regular rainfall and a large enough volume of rainfall. And the other thing that this is linked to is the climate as well, because we don't want it too hot because this will result in evaporation. So we want it not too hot to reduce evaporation losses. Obviously, if we build it in the lowlands where it's very warm and hot, then we'll have a lot of evaporation taking place. However, if we built it up in like the upland areas where it's going to be naturally a lot cooler, you'll have less evaporation. Now, pollution risk is really quite a serious thing to consider, and this is based upon the land use within the catchment. Sewage and manure from human habitation or agriculture typically decomposes quite quickly in a reservoir, and there is a large volume of water in the reservoir, so it dilutes it away a bit as well. However, we can have some things build up because they are persistent. So things like pesticides and herbicides from agriculture, these are persistent and can build up within a reservoir. Or we might have toxic pollutants from things like industry. So this might be things like mining or like metal smelting. These produce persistent pollutants that will remain in the water for a long time and be difficult and expensive to remove. And if we have a forest that gets flooded, this can cause the anaerobic decomposition of this dead organic matter at the bottom of the reservoir, and that can result in these anaerobic conditions, methane to be produced. And this is a strong greenhouse gas, which means that it has quite a significant effect upon global climate change, which is quite a serious consideration when talking about new dams and managing older ones as well. So, sedimentation. Reservoirs are typically built in areas which have steep sides around them. Steep sides means that you have fast moving water flowing down them. And this can mean a high rate of erosion, either within the immediate catchment of the reservoir or in the catchment above it. And this means the water will be quite turbid, and this can build up sediment in the water. Now, because the water is static, this means that the particles of suspended solids will, over time, let's just draw a cross section of my reservoir. There we go. So here's my dam. These particles will settle out over time, and you'll find that they will build up layers of sediment year by year, and this fills in the reservoir, reducing the volume. That sediment also would have been useful downstream for things like adding nutrients to the soils nearby. So this sediment reduces the volume of the reservoir and actually shortens the lifespan of the reservoir as well, unless you can empty it out. One of the things we can do, though, is plant trees around it, so afforestation. This afforestation helps intercept rainfall, slowing the rate of surface water runoff, and this can mean that we have less erosion in the surroundings of our reservoir. If they're conifers, though, this can mean that they make the water acidic. as one of the byproducts of a conifer plantation. So that's something to bear in mind. And then we've got infrastructure. So it can be expensive to build all the pipe work and water treatment works and to pump water long distances. So sometimes it's actually better to build the dam close to demand. So find a convenient site as opposed to the perfect one for building a reservoir. So it might be a bit smaller or a little bit more expensive, but it pays off in the long run. And then we also have existing land use conflicts. So urban areas where there's large populations, it's going to cost a lot of money to pay those people, compensate them to leave, or protected sites, things like habitats that have specific international protections, things like SACs or Ramsar sites or things like that. Typically, agricultural land is seen as a lower value, so that in especially the Western world, so like the UK or somewhere, that is where you would find reservoirs being considered. However, in other countries, it might be that agricultural land is in particular shortage, so then you are going to prioritize that over other uses. Now, moving on from reservoirs, but similar to it, you get estuary barrages. Now, these are a type of reservoir that you build in an estuary. So we have the sea out here, and we build a dam across the mouth of an estuary or a bay. And this means that the river that used to flow directly into the sea is actually prevented from going into the sea, and it fills up this estuary. Now, this is really useful because it avoids land use conflicts. No one's using that land, it is just an estuary. However, it can change intertidal habitats, things like wetlands, which are particularly valuable, or perhaps mangrove swamps. They can prove to be a barrier to shipping. And if there's any pollution in the catchment, it will work its way down the river and end up polluting your estuary barrage, which is particularly difficult to deal with because it drains the entire catchment into that one area, so it's quite difficult to avoid. And the last alternative that we're going to look at is desalination. This is where we heat the water up until it evaporates and boils. It might be done under a partial vacuum to make it more efficient, and then you condense it, and then you collect the condensate as fresh water, and all the salt gets left behind. However, this is really energy intensive and therefore expensive, and typically done in locations where there is no alternative. So there's not enough fresh water, and potentially they have cheap energy. So places like Saudi Arabia with their oil reserves might find it's actually relatively cheap to do desalination on the large scale, as opposed to somewhere like Malta, perhaps, where they have to buy that energy in for desalination.